Okay, so let's rock through some examples here of what are we doing? Oh, well, we're making it maths, of course. So we've got linear equations, fractions with constants in the denominator. Now, what's the difference between a constant and a variable? Well, constants are constant, they stay the same. So numbers like 7, that's going to stay the same, it's always 7. But the number like x, well, x is variable, it could change, or, you know, y squared, that was quite a funky y. So, you know, variables x and y versus constants like 7. So for these, we're always going to have constants in the denominator. What's a denominator again? Well, it's the kind of the bottom part of the fraction. So there, that's a constant, that's 5. Okay, so I kind of got a few, and I'm going to do this first one in two slightly different ways, and you'll see why. So we've got 2x divided by 5 equals 4. Now, maybe what would your idea be to try and solve this equation? I'm always fascinated because you could have a few ways. It could relate to one of the ways that we're going to do here. It could be a different way. It could definitely be valuable. I'm going to kind of describe one that isn't going to be one of the ways we're going to do it directly, which is more, well, you've got some number here and you're dividing it by 5 to get 4, which means this top number here, let's kind of highlight this number here, must be 20, because 20 over 5 is 4. So 2 times what gives you 20? X must be 10. So maybe that's your thinking, and we're kind of going to do that in, as I say, two different ways, that idea, but we're just going to do it in a more structured way so that we can keep solving more complicated equations. So the one way I'm going to think about is, let me just rewrite this actually. 2x over 5 equals 4. And the one way I like to think about this is to go, well, I don't want that 5 there. So if we multiply this side by 5, well, that's like going 5 over 1, and those are going to cancel, and you'll just be left with 2x, no more fraction. And then, of course, what you do to one side, you do to the other. So multiplied by 5, 2x equals 20, which matches our idea at the beginning, right? That top must be 20. Okay, and then 2 times what gives you 20, or divide both sides of the equation by 2, and x equals 10. Okay, so that would be one way, x equals 10, kind of matches our thinking. The other way maybe to think about this is 2x over 5 equals 4. Now this time, instead of saying, oh, let's get rid of those fractions, let's work with the fractions and let's get a lowest common denominator. Now, what is our lowest common denominator? Well, I'm just going to say LCD from now on. What is our LCD of these two, of the left-hand side and the right-hand side? Well, the right-hand side, maybe it would be easier if we wrote that over 1. So our lowest common denominator is just 5. So if we wrote both sides over 5, nothing needs to change on that side, but kind of we've thought about this idea of, well, if that times by 5 to get that 5, what you do to the bottom, you do to the top, so that it's an equivalent fraction, and therefore you've got equals 20. Now, if the denominators are the same, it kind of makes sense that the numerators would be the same. So 2x must be 20, because this numerator must be this numerator, because the denominators were the same. Okay, and we get to the same answer, right? So finally, x equals 10 as it did in the first place. Okay, so either way seems as good as the other one, and go for whichever one makes more sense to you. But as I said, kind of planting seeds for future ones. So let's try another example. Solve x. X over 3 plus x over 2 equals -2. Now, what do you need to do when you add fractions? Well, we need a lowest common denominator. So it would be useful if on the left-hand side, we had this as the lowest common denominator. And what is our LCD of 3 and 2? Well, it would be 6. So we'd have 6 and 6. So therefore, we'd go, oh, well, we need to multiply that by 2. What you do to the bottom, you do to the top. So therefore, you've got 2x. And for our second fraction, well, times 3 is times 3. So we got 3x. And because the denominators are the same, you can add your numerators, right? Just looking at the left-hand side. Now, I think it's useful to skip showing this step here. It's correct, but we make, like, what have we gained by showing that step as opposed to we're going to be adding with our LCD? So let's skip that step. And on our right hand side though, we've got -2. Now we want to write that over 6 as well. So I'm just going to show it in that step. So this was -2 over, I don't know, going crazy with the colors as always, right? So we've got -2 over 1. So what do we need to multiply 1 by to get to 6? Well, of course, we need to multiply by 6. What we do to the bottom, we do to the top. So that's -2 times 6, which gives us -12. Okay, now what's nice is that we can use that idea of denominators are the same, numerators must be the same. So let's kind of show this step, why not? 5x, we got the -12. Now they've got the same denominator of 6. Therefore, the numerators must be the same. So 5x equals -12. So therefore, how are we going to find out what x is? Well, divide by the coefficient. So 5 in this case equals -12 over 5. Okay, so our logic in this case was to use that lowest common denominator, which in this case was 6. Okay, so let's see how that helps us with something like this question. We've got denominators of 4, 6, and 2. So we're going to write this whole side over a lowest common denominator. So the lowest common denominator for both sides, so for 4, 6, and 2 is what? Well, our lowest common denominator is 6 because, no, wait. No, it's not 6, is it? Why is our LCD not 6? Well, 4 doesn't go into 6 so nicely, does it? 6 goes in there, 2 goes in there. But what about 12? Let's try that. Does 4 go into 12? Yes, 6, 12, 2, 12. That looks a little bit better. Sure. Caught myself out there. Almost, right? Almost. Okay, so now what we can do is, again, just trying to show some efficiency here of, we want this there, so we need to multiply this by 3. What you do to the bottom, you do to the top. So in this case, 3x plus 1. We want to multiply that whole numerator by 3. So I'm showing it with this bracket. We'll distribute in the next line. Okay, then we've got this negative over there, so I'm going to put a negative. And we've got x minus 1. Now we need to multiply 6 by 2. What you do to the bottom, you do to the top. So x minus 1. So it's an equivalent fraction. Okay, and on the right hand side, what needs to be in the numerator over here? Well, we've multiplied this by 6, multiplied this by 6, so we get 18. Denominators are the same, so therefore numerators are the same. So I think we're going to kind of not write this 12 and this 12. We're not cancelling them out, but I'm going to distribute this at the same time. Because why write out that exact same step and then distribute? So in this step, 3x plus 3 minus 2x plus 2 equals 18. So now we've got a much simpler linear equation to solve. So therefore we can solve it. 3x minus 2x. Well, that's just, I don't know, what color should we go for? Should we go for this light blue? Sort of comes out, right? X, 3 plus 2 is 5 equals 18. Subtract 5 from each side. Maybe we can show that. Minus 5 minus 5. So therefore, x equals 13. And if you really wanted to, you could check that this works. 14 over 4, 12 over 6, 3 over 2. I don't know. Hopefully that works. If you spotted an error, jot it down now. If not, then just say thumbs up. But I'm actually going to be lazy and not check and just see if you spotted anything. As I said, there's no purposeful thing. I'm just wondering, maybe I did make a mistake. Okay, so then we should be happy to go on. And if I see a whole lot of yeses, then I'm going to hurriedly go back and look. Okay, so let's keep motoring on here. We've got 2x. Now, we're going to do the same idea of LCDs. I'm just to be safe, I'm going to put this whole thing over 1. And the first question is, what's our lowest common denominator? Well, it's 9. Notice that it's not 27 because 3 goes into 9, 9 goes into 9, 1 goes into 9. So what we've got is, we've got over 9 over 9. Now, yes, show this step. I know that we're going to discard these and just look at the numerators in the next step, but it shows our thinking nicely, our LCD. It's a useful habit to still show this step. And I'm reinforcing that because, I said, let's look at what we can do efficiently, but what steps can we still show that show our thinking nicely? So this needs to be multiplied by 3. What you do to the bottom, you do to the top. 3 times 2x, you know what? May as well write 6x over there. And we've got minus. So let's go green. So this minus over here, minus, and we're subtracting this entire numerator. So notice how important those brackets are going to be. In fact, why are those brackets so important? Well, when we distribute this in the next step, look, a minus times a minus is going to give us a plus. So if you didn't have the brackets, you would have had minus x minus 2 in the next step, but it should be plus 2. And seeing as we're already doing that, 6x over there. Let's just fix that x a little bit. Okay. On the right-hand side, we've got x minus 1. Again, let's do brackets. We need to multiply this by 9. So we're going to do it bottom and top. So 9x minus 1, which we're going to distribute in the next step and get 9x minus 9. Okay, so after all of that, what's your final answer for x? Okay, well, let's do it. 6x minus x is 5x. And that side's going to be 4x, right? 2 plus 9 is 11. So x equals 11 over 4. Let's just check. I seem to be skipping a few steps along the way. 6x minus 5x minus x is 5x plus 2 equals 9x minus 9. I've subtracted 5x from each side here so that I've got positive x's here. But if you wanted to and you subtracted 9x, you'd have minus 4x on the left-hand side. If you subtracted 2 from each side, you'd have minus 11. And therefore x equals minus 11 over minus 4. Therefore x equals 11 over 4. Doesn't matter if you do it that way or that way. Okay, onwards, upwards, right? Ready? Yeah, I'm ready. Okay, so, is that it for examples? Oh, I was just getting into the swing of it. Okay, exercise 18 is yours for today and tomorrow. Oh, that seemed pretty good, right? Do you know what it's time? Where do we need to make it? Oh, just write down some interesting fact. Write down your positive word for the day. Cool. Well, I think my positive word, good positive word, make. That's what I'd say. Make it, math, right? Make. It's pretty positive. Okay. Well, I'll see you again.